All right. Well, welcome to the Global Math Department, everyone. My name is Lee Natero, and I'll be your host tonight. Tonight, we're going to be hearing from Kevin Dykema on From Math by Memorizing to Math by Understanding. Before we begin our session, I'd like to tell you a bit more about the Global Math Department. The Global Math Department is an organization that is run entirely by volunteers. To keep the free, high-quality PD, we need webinar speakers, webinar hosts, and writers for our newsletter. Newsletter writers share about an area of math or math teaching that resonates with them or discusses recent math blogs that help teachers reflect on their practice. If you'd like to volunteer or know someone who would be great in any of these areas, please have them email us at globalmathdepartment@gmail.com or have them reach out to us on Twitter. Before I introduce our speaker, I'd like to explain how our webinars work. Our webinars are recorded and are available about 24 hours after the meeting ends. To view the recording, you can use the same link you used to get here tonight. The Global Math Department community prides itself on being friendly and supportive. The chat room is available for topical and general conversation throughout the meeting. And if the chatter gets busy, I'll be sure to catch your questions for the presenter to be addressed at the end of the presentation. If you haven't already done so, please introduce yourself in the chat, telling us what you teach, where you teach, and what your Twitter handle is, if you have one. Glad to see people from California, Nevada, Colorado, Wisconsin, Washington. And also we have some international folks with us here tonight. From India, Burbank, California, Pennsylvania, all over the place tonight. All right, so our webinar speaker is Kevin Dykema, and he's going to be sharing on the topic From Math by Memorizing to Math by Understanding. Kevin is president of the National Council of Teachers of Mathematics, NCTM. He has taught 8th grade mathematics for over 25 years and is currently at Mattawan Middle School in Southwest Michigan. Dykema is a frequent speaker before mathematics education audiences and has co-authored Productive Math Struggle, published by Corwin. He's also written several articles for Mathematics Teacher, Learning and Teaching Pre-K-12. Dykema loves working with others to help improve mathematics education for each and every student. Welcome, Kevin.
Thank you very much, Lee, and thanks for those of you joining us live, or thanks for those of you who are watching the recording. I'll confess, this is my first live one in many years. I tend to watch the recordings 9 o'clock Michigan time. It's getting pretty close to bedtime for me normally. My email address is there. And if you want a copy of the PowerPoint, I am happy to provide you with a copy of that PowerPoint. Just send me an email and tell me you were at the Global Math Department webinar, then I'll know which PowerPoint to send you. So let's dive in. As Lee shared, I am the current president for the National Council of Teachers of Mathematics. So we're gonna do a quick 2 minutes, what is NCTM? So there's our mission statement. And the thing that always strikes me is that each and every student. And what can we do to best meet the needs of an ever diversifying group of students that may be in our classrooms? So one of the more visible ways that NCTM does this work is through some conferences. So if you're a conference lover and you have nothing else to do in a couple of weeks, come join me in Baltimore. The weather will be decent, hopefully. Hopefully it won't be full of snow. If you're more of a virtual type of a person, the end of March, we have a virtual conference. And our annual conference next year is in Washington, D.C. at the end of October. We also have a variety of different position statements that are available. We have a monthly journal, that Mathematics Teacher Learning and Teaching PK to 12. There's a My NCTM, a little social media platform available to members where you can pose a question and people respond, and you can get a lot of wonderful ideas. And there are a bunch of classroom resources available also for members. We do have some publications, and we'll talk about some of these in our time together this evening. We also have some grants and awards. So if you're saying, hey, I want to get money to go to a conference, to do some research in my classroom, to get some supplies for my classroom, to attend a professional development session, you see there is a website, and there are lots of different grants, lots of different awards for that. If you are a member, the next time you renew, there's a discount code. If you're not yet a member and you're saying, hey, I want to join NCTM, it's been on your to-do list, there's a discount code that'll save you $20 or $10, depending on which level you go with. The code is not top secret, so you can share it with whomever you want. The code is good until next October. Then next October, it's going to change to board 24. So we try to keep it nice and simple. And again, you can find out more information there as our website. But let's dive into the purpose of our time together this evening. So there's really sort of three questions I want to address. Why do we care about this notion of moving math from math by memorizing to math by understanding? What does it look like? And how do we get our students willing to engage in that type of mathematics learning? So let's jump in. First, we'll start with a why. Why is this such an important topic? And why should we move math away from just memorizing a series of steps and get them to that good, solid understanding? Selfishly, I want my students to fall in love with mathematics. And I would argue, when you understand something, you start to appreciate it more. If you don't understand something, you probably don't really enjoy doing it and don't want to continue to do that. And I want my students to develop a love for mathematics. So it's not me just sort of mathing, geeking out in the middle of class. They can join me in that journey. There's an ancient saying that I absolutely love, and you see it on the screen there. And that really strikes me, that for so many of us, we may have grown up in a time where our teachers just talked at us. And we remembered it for a couple of minutes, but then we quickly forgot it. It's when we get our students doing something, when they get to actively engaged, that we get to that understanding stage. And I want it to be math by understanding. I want them to know what's going on. There's also a definition of insanity that I'd like to talk about. And here it is. We can all think of a colleague. None of us watching the recording, none of us here live, of course. But we can think of a colleague when they reteach something, they just say it slower or maybe a little louder. And that doesn't work for students. For most students, just hearing it word for word the same is not helpful. They've got to see things in a different way. And I think when we get to understanding, it's a different way for some of our students. Some of our students may have been good rule memorizers. They may have been lousy rule memorizers. Either way, it's a different level of knowledge when they get to that good, solid understanding. So NCTM has a Catalyzing Change series. Some of you may be familiar with it. Some of you may not be familiar with it. It started out with a high school version of the book. And then a couple years later, we released a middle school version and an early childhood and elementary mathematics version. You see a website there. There's a bunch of other supporting information on there. Sometime later on this year, we're going to release the success stories from Catalyzing Change that have some early indicators of schools that have made some significant changes, some districts that have made some significant changes in the way that they've taught mathematics, and to provide us with some real life examples of what it might look like. But in that book, if you're familiar with it, there's 4 key recommendations. I really want to hone in on that recommendation number 3. And I look at getting our students to understand math as really an equitable way of teaching. Each and every student deserves to understand what's going on with that. And again, those recommendations are the same across the grade levels. The verbiage may look a little bit different depending on the grade level, but it's not like any one of these recommendations can be done in isolation. It's not like just broadening the purpose of learning math is done. We're like, oh, all of our students are going to be more successful. No, it's a combination of broadening the purposes of learning math, creating those equitable structures, implementing that mathematics instruction, and going deep with that mathematical understanding, and having that common agreed upon pathways for our students to move through from the PK to 12. And then we have these 8 effective mathematics teaching practices. One of the reasons I love these 8 effective mathematics teaching practices, they've been out for about 10 years now, and nobody's really clamoring and saying, hey, one of those 8 isn't all that important. And I don't hear very often somebody advocating for, oh, there really should be a 9th effective mathematics teaching practice. Research has shown when we do these 8 things, we're much more likely to be successful with our students. But I really like this view better. And this view, I noticed on the bottom, there's 5 of them that are really sort of saying the same 2 things. Get your students thinking about math, and just as importantly, get your students communicating about math. And if I think if there's any one shift that a teacher can make in their classroom practice to better meet the needs of our students and to start to move it to math by understanding away from math by memorizing, it's really this notion of get your students talking about math in math class. And we'll come back and I'll share a couple of ideas of how to do that in a little while. And we know that progress was being made, and then COVID hit. And in many places, in my own classroom, math instruction changed. I'd like to think that pre-pandemic, I did a decent job, not a great job some days were better than others, but a decent job of really trying to implement these 8 practices. And then my teaching changed during the pandemic. In my district, as in many other districts, when it was March of 2020 and everybody thought, oh, we're going to have just an extended spring break. And we quickly realized, oh, that extended spring break isn't really going to be an extended spring break. We're not coming back into face-to-face instruction. Our district made the decision not to have any synchronous classes. So my instruction switched from all that good, rich problem solving, all that good classroom conversation, to me making 5-minute videos saying, here's the first thing you do, here's the second thing you do, here's the third thing you do. And oh, if your internet's kind of lousy connection, I'll put a copy of some notes and step-by-step directions. Here's 4 problems for you to practice. Any more than 4, and they may not be likely to do it. And all you really have to do is just plug in those numbers. And we know that that's not effective for our students. And that really showed up in the recent NAEP results. And I like to cover a part of the NAEP results because NAEP back in the look, all of a sudden our scores plummeted this last year. Not a surprise to any of us in the classroom. It's to be a surprise to some policymakers. But I think that the decline in test scores really shows here's the third thing is not effective. It's much more effective when we were having those rich classroom conversations. So I urge all of us, let's go back to that pre-pandemic teaching in many respects and get our kids actively engaged, get them thinking deeply about the mathematics. So I want you to find the chat box a moment. And in that chat box, I want you to just type in 3 words that you associate with struggle. So 3 words that you associate with struggle. If you only have 2 words, great. If you have 4 words, that's great. It's not any pop quiz or anything. And we're going to jump over this. I know my screen's going to look goofy for a minute, but I want to be able to see that chat box a minute. So 3 words that you associate with struggle. Yeah, challenging. Thank you. Progress, opportunity, challenge, productive, difficult, frustrating. Perseverance, math, absolutely for a lot of our students. Essential for learning. Thanks. Too hard. Students doing the work. So lots of things there. And oftentimes I notice that people's initial thoughts about struggle are negative in connotation. That for many people, they view struggle as a bad thing. And I want to argue it's a necessary part of learning. And before we look at what does that look like in the classroom, I want to look outside of the education world for a moment. I want to think about learning to ride a bike. There's a lot of struggle involved with learning to ride a bike, and yet we value that struggle. We recognize it's through that struggle that true learning occurs. In fact, we value it so much, we provided a scaffold. We call it training wheels, but in many respects, it's a scaffold. It's not like someone is riding the bike with training wheels. They're learning to ride that bike with training wheels. When I think about manipulatives, used very often in elementary classrooms, unfortunately not used as much as they should in middle school and high school classrooms, but we're not doing the math, with the manipulatives. We're learning the math with the manipulatives. And in many respects, the manipulatives are a little bit like training wheels, that we've got to use those to help us develop that good understanding and then move past that stage. And I'll help illustrate that in a couple of minutes. When I think about learning to swim, there's definitely a struggle involved with learning to swim, and we value that struggle. And I'm always struck by the role of that swim instructor. That swim instructor is not doing the work. It's not like all the work. It's not like the swim instructor is grabbing the child's arms, propelling them through the water, grabbing the child's legs and kicking them. No. The swim instructor is there saying, you're not going to drown. You're not going to die. I believe in you. You know what to do next. And I wonder how often I am not like that swim instructor. I wonder how often I am doing all of that intellectual work in the classroom and my students are just sort of along for a free ride. So when we're learning to drive, when we're learning a new dance move, when we're learning a new instrument, when we're learning a new sport, when we're learning the words to a new song, we value that struggle. And we recognize it's through that struggle that true learning occurs. But yet in the math classroom, so often we try to avoid having our students get with that struggle. Now hear me carefully. I'm not saying I'm advocating for a class full of tears where everybody's saying, I don't get it, this is impossible. That's not the kind of struggle we're talking about. I like to use NCTM's definition of this notion of productive struggle. Our job should be to provide the opportunities, the supports, so that students can grapple. And I love that word grapple and what it sort of connotes with mathematical ideas and relationships. I want them to be doing that good, rich thinking. I want them to start to make connections. I want them to begin to find patterns. But I want to do that equitably. And in that catalyzing change, my favorite part of the high school book, there's one table that shows those 8 mathematics teaching practices and how to do those equitably. And when we look at that supporting productive struggle, allow time for students to engage. It takes time for them to think. It takes time for them to start to make those good connections, but it is time that is well spent. It may take you a little bit longer at the beginning, but it pays off down the road because you're not having to constantly reteach the same things over and over and over again. And we have to hold high expectations for each and every one of our students. This is not good. This is not just for our students who we see as mathematically capable, that we allow them to grapple. Those that we perceive as, math just isn't your thing, we tend to do the drill and kill, worksheet after worksheet after worksheet with them. No. This rich, deep thinking, this math by understanding is so vital for every single one of our students. So that's a little bit of the why. So what does it look like? And I want to just provide a couple of different examples at different grade levels of what do I mean when I think I want to shift it to math by understanding rather than just math by memorizing. So I'm going to start out with an elementary problem. I'm going to pose the problem in just a minute. I don't care if you actually find the answer. I want you to think about how would you go about finding the answer. If you want to share your strategy in the chat box, that's fine. If you don't want to share your strategy in the chat box, totally fine. So again, I don't really care about the answer. I want you to think about how would you go about figuring out the answer to this problem. So 245 plus 98. What would you do to solve that problem? So I'm going to give you a few seconds, 15 seconds or so, to think about how would you go about finding the answer to 245 plus 98. So from doing this with a variety of different groups and a variety of different teachers and other educators, I know there are some very common strategies. For many of us, we may jump and say, oh, it's really 245 plus 100 and then subtract 2. Other people sometimes say, oh, I'm just going to change the problem a little bit and make it 243 plus 100. Sort of steal 2 from 245 and give it to 98. Some may do some work with place values and say, oh, 245 is, I don't know, close to 250. 98 is close to 100. So it's close to 350. I was 5 over, 2 over. Lots of different thinking. Some of us might have done the good old stack them up and add them up. When I was a student, that was the one and only one strategy that we were allowed to do, that stack them up and add them up. And I hated a horizontally written problem because the first thing you had to do was rewrite it vertically. And my teacher never just allowed us to write the 98 under the 245. Oh no, we had to rewrite the entire problem there. But here's my point. If it's okay for us as adults to think through that problem and not just jump to the standard algorithm, why do we force our students in so many cases to use a standard algorithm? Now, there's nothing wrong with a standard algorithm. Some people may disagree with me, but I do believe that there's a time and a place for the standard algorithm, but it's a time and a place. It's not jumping straight to that standard algorithm. And I think it's so vital that we allow our students that opportunity to think. If it's okay for us as adults to think, it should be okay for our students to think. I want to switch gears here a minute, and I want to think about fractions. I was in middle school in the 1980s. When I was in middle school, my 6th grade year was primarily fractions, decimals, and percents. 7th grade year, very little new. We just did more work with fractions, decimals, percents. 8th grade year, very little new again, almost all exclusively fractions, decimals, and percents. And you see the results of 3 straight middle school years of fractions, decimals, and percents. People still didn't understand that. And we know with the standards that we have today, it's not primarily 6th, 7th, and 8th grade that we do fractions, decimals, and percents. A lot of that work is in 3rd, 4th, and 5th grade. And it's not just fractions, decimals, and percents in 3rd, 4th, and 5th grade. There's a whole lot of other stuff. And yet, in so many places, we still just teach fractions the same way that we may have learned or memorized however many years ago. And I want to look at what's another way that we can maybe do a little bit of work with fractions. And I want to think about simplifying fractions or finding equivalent fractions. So instead of just telling my students, here's how you find an equivalent fraction, maybe I grab some fraction tiles or have them grab some fraction tiles, fraction circles, fraction squares, fraction towers, fraction whatever manipulative you have. And maybe I ask them, hey, you represent 1/2. And then maybe I say, all right, using just a single color, I don't want any funky 2 different color combinations right now. Just using a single color, see if you can find other fractions that are equivalent to there. And you see up top, I made a list using the common set of fraction manipulatives. We can get 1/2, 2/4, 3/6, 4/8, 5/10, 6/12. Maybe I do it with a couple of other fractions as well. So we have a couple of different sets of fractions there. But right now, we're still sort of at that training wheel stage. We've used the manipulatives to find those equivalent fractions. I want my students to be able to get to that understanding stage. I don't want them to have to continually use those fraction pieces. I want them to start to see those patterns. So maybe say, all right, do you see any patterns in there? Do you see any way that maybe for 1/2, if I tell you the numerator is now 10, what's that denominator going to be? Or maybe for 3/4, if I tell you that denominator is 40, what's that numerator going to be? Ask that a few times. I tell my students, don't tell us how you got the answer, just tell us the answer, because I want students to have the opportunity to find that pattern. And all of a sudden I start hearing, oh, and that's my favorite sound in a math classroom, because I know that's when they're starting to make those connections. They're starting to get to that understanding stage. And then I ask a student, all right, put it in your own words. And oftentimes they say multiply the top number and the bottom number by the same thing to find an equivalent fraction. They generally don't right off the bat say find the numerator and the denominator. They call it the top number, the bottom number, and I'm fine with that. I can supply that academic vocabulary later on. And then with some 8th graders, sometimes I like to sort of go backwards and say, all right, if I told you 6/12, how can I go back to 1/2? And my 8th graders who need a little bit of extra support sometimes will say, oh, all you need to do is divide the top and the bottom by the same number. And then they look at me and say, how come no one's ever told us that? That's all we had to do to find an equivalent fraction. And so what we did, we told you in 3rd grade. We told you in 4th grade. We told you in 5th grade. We told you in 6th grade. We told you in 7th grade. I told you in 8th grade, maybe even a little slower and louder. But it's not until they see it, it's not until they get the opportunity to start to make sense, to find that pattern, to get to that understanding stage, that all of a sudden it connects with them. And the frequency of errors is greatly reduced. Let's look at another example. Think about solving equations. This is a great middle school problem. Most students can do it successfully, not maybe initially. It takes a little bit of time, but most students can do it successfully, and most students end up using the distributive property. Let me give you a little sneak peek into a Michigan classroom. So I may give my students this problem, they do it, and I say, all right, hey, I'm so glad that almost all of you got the problem right. Let me show you another way to do this problem. In Michigan, at least, that's clue for tune the teacher out for the next 3 minutes, because who really cares about another way? We've all gotten the answer correct. We can just keep doing it this way all the time. But what about if instead of me just saying, here's another way, what about if I do this? What about if I say, hey, Camden says you don't have to use a distributive property. Camden, by the way, is not a student that I would have that year. I come up with a different name. Otherwise, all of a sudden, everybody starts asking Camden, oh, did you really do it that way? Or if Camden's not in that class, they start saying, oh, do you really think Camden did it? I don't want all that time wasted with that. Pick a name of a student you don't have that year. Present the other solution, the other way of solving that problem. Ask the students, do you agree with Camden? Now, I'll confess, the first time I started using this strategy, I only asked questions like this when the answer was yes, you should agree with Camden. And my students, as soon as they saw something like this, they would say yes, and they try to come up with a reason. So you have to make sure, if you're going to use this strategy, that you throw some no's in there. So maybe you pull a common error out. And it's something that, and I know when students first start adding 2-digit numbers, here's a very common error they make. So pull that Band-Aid right off and say, here's a strategy. Does it work? Something where we're putting that responsibility on the students, getting them actively engaged with their thinking. We're not just telling them, here's what to do. We're allowing them to wrestle through with that. Let's shift gears again. Let's think about the vertex form. When I learned the vertex form of a parabola, I just learned the H moves it left, right, the K moves it up, down, the A makes it thinner or wider or flips it upside down. We were just told what to do, and I'm sure we practiced it over and over and over again. But what about if instead of me telling them, what about if I use a tool such as Desmos? And I start out with maybe y equals x squared. And I say, all right, you change the number inside the parentheses and see what happens to the graph. There's my x minus 3 squared. There's the x plus 5 quantity squared. What are you noticing about that? My students are getting to that understanding stage. I'm not just telling them what to do, they're seeing it. They're starting to make those connections. Or maybe I take it a step further and I just type in the general equation that y equals a times that quantity x minus h squared plus k and say, hey, let's make a slider for it. What's happening as we change that h value? They recognize, sure enough, it's going horizontally. What's happening when I change that k value? Sure enough, it really is moving it up and down. What's happening when I change that a value? Lo and behold, it's stretching it, shrinking it, flipping upside down. And then because I teach 8th graders, you have to get all 3 of them going at the one time for a little bit and watch the parabola bounce all over the place. Pause it, have some conversations, and continue with that. Certainly not the way that I learned about the vertex form, but it's a way that's so powerful for our students. They start to make those connections. They see what's going on. And when they see what's going on, they're getting to that understanding stage. They're starting to make sense of that. They're not just sitting there and nodding as the teacher is explaining and saying, does anybody have any questions? And they all shake their heads no, even though they're not even really mentally engaged with that. Let's do something to get our students to that understanding stage. Maybe when I think about the properties of exponents, maybe I switch how I do things. And instead of me just telling them those different properties, and this has nothing to do with the algebra tiles, but I know it gives me a little bit of a blank space that I can write. Instead of me just telling them, hey, x to the nth times x to the nth power is x to the n plus m, and it's all just as pure memorizing. What about if I say, all right, we're going to find a shortcut. You rewrite x squared times x to the 4th, you write it out in expanded form. So there's x squared There's x to the fourth. Now you rewrite it in exponential form. Give them a few of them, all of a sudden they start to find that shortcut. When they get to that shortcut, they're getting to that understanding stage. And just as importantly, later on, when you may have a problem like this for whatever reason, and they're starting to think, oh no, is it 3 times 2 or is it 3 plus 2? A student who's developed that understanding, they can think of this as two groups of 3x's. Oh, there's my 6x's. I have 7 more x's. That gives me to the x to the 13th. They're not having to play 50-50 guesses anymore. They have some opportunity because they start to make sense. They know what's going on. They're finding that patterns. They're actively engaged. They're feeling good about themselves. They're feeling like they're capable of learning mathematics. So those are just a couple of examples of what do I mean by that. Another great resource, I think, to find some problems that really make our students think is open middle problems. You can just Google open middle math. There's a website that has lots of them on there. Some examples. For most of them, it's using the digits 0 to 9 at most once, and the students have to make a true statement. So for this one, they can choose, the two fractions or two sets of two fractions, decide if it's a division or multiplication, an addition or subtraction, they want to find an equivalent. Some students may be using some strategies. Some students may just be doing a variety of problems until they find the answer. There's a whole bunch with two-step equations, and you want to find the smallest sum of the x and the y or the greatest sum of the x and the y, all the way up until calculus. I'll confess, I have no idea what the derivative power rule is anymore. That's way past my normal day-to-day life as an 8th grade math teacher. At one point I knew it, but there's stuff for calculus there. So it's all the way from kindergarten all the way up into the calculus ways. But we've got to do something to get our students actively engaged in that thinking, getting them shifting from just memorizing a set of what appears to them to be random set of rules and get them to this understanding stage. So I want to provide a couple of examples of what do I mean by getting to that understanding. But now I want to shift our gears. We've looked at the why is it so important. We've looked at the what does it look like in the classroom. And now I want to talk about how do we get our students to do that? Because it's tougher for our students, or they view it as tougher. They think it's much more powerful if the teacher just tells them what to do. They try to memorize a set of steps. And when I do some tutoring of students, so often I'll tell my students, what, I didn't memorize that. Here's how I think about whatever the problem may be. And when I share some of that thinking, they're like, oh, that makes a whole lot more sense. We were just working with odd and even functions this week, I think, with one of the kids that I tutor. And we were talking about, what is the overall shape of an x to the 5th and how do you decide if it's positive or negative? And I shared, here's how I think about it. And she said, oh, that's so much more nice than me just trying to memorize and make a whole little table. But so often we just tell our students and they become used to being told what to do. Let's get them to think. So how can I do that? Because I know I want my students to be engaged in that rich discourse. Because I know when they're talking about math in math class, they're that much more likely to be getting to the understanding stage. When I think about that discourse in there, and part of that's using that student thinking. And when I go back to that catalyzing change and think about different strategies and different things to help make it equitable, I notice this bottom bullet, promoting a classroom culture in which mistakes and errors are viewed as important reasoning opportunities. And many of us say we do love mistakes. We love it when our students share a mistake. But then I wonder, how do we react when we make a mistake? And what message does that send? How do I react when I make a mistake? I have this weird habit sometimes of what I write on the board is not what comes out of my mouth. I may say 8 plus 5 is 13, and I write 18 on the board. My students laugh and saying, why are you laughing? 8 plus 5 is 13. I turn around and I have some different number written there. How do I react in that moment when I make a mistake? How do I react in a moment where I lose a negative sign or I did something wrong and then realize that? If I say, oh, you guys, I'm so sorry. I'm so embarrassed. I can't believe I did that. Is that really promoting a classroom culture? If I'm telling my students it's okay to make a mistake, they have to see me react positively when I make a mistake. And I would also argue, for the teachers that tell the students, oh, I purposefully made that mistake to see if anybody was paying attention. Baloney. Quit lying to our students in that respect and do that. Just own up that you're a human being. You made a temporary error. We're going to fix it and move on from that, because that sends that same message to our students that it's okay when you make a mistake. Fix it, move on from there. So I think about the how do I get my students to want to be engaged with this rich, deep thinking that's required. I think there's really three different B's to consider. And the first B is belonging. I want them to feel like they belong in my classroom. Just telling them you are a math person is not enough. And I love these shirts, and I love that as a math education community, we're telling everybody that everybody is a math person, but just telling somebody that, they don't believe it. In my role as NCTM president, I get the privilege of going to a variety of different conferences and speaking at different conferences and working with teachers. I always dread when I get in the Uber at the airport or hotel at the airport, because I know the person's going to ask, what do I do? And I've got to make a decision. Do I just say I'm an educator and leave it at that and hope they go on to something different? Or do I say I'm a math person or I'm a math teacher, because I know I'm going to hear their math horror stories. I'm going to hear about how they didn't appreciate math and how they didn't like math. And just telling that person in that moment, oh, you know what? You really are a math person is not enough. We need to do more than just telling them that. That's not going to be enough to get our students to feel like they belong in our classroom. So I know we're past the first week of school, but if you file the way for next year, if you've never used Sarah Vanderwerf's name tense idea, it's great. It's not so great for early elementary grades, but it's definitely great for the later elementary into middle school and high school. Just Google Sarah Vanderwerf name tense, you'll find it. She's got some great sort of step-by-step what do you do, and a great way to start to build those relationships with the students, get them starting to think mathematically, for you to start to get a little eye into their mathematical journey. I also use index cards. As a middle school teacher, depending on the year, I may have anywhere from 120 to 150 students. I can't keep track of what all of their interests are. And a lot of times on Fridays, I'd like to walk around the classroom as they're working on their math tasks for the day, as they're working on some independent practice, as they're finishing up an assessment, whatever the case may be, and just ask them, anybody have anything fun they're doing this weekend? But then I find I got to jot myself notes, because I'm going to forget between Friday and Monday. And the look on students' faces when they walk into the door on Monday, and I'll say, oh, how was your lacrosse match? How was your swim meet? How was going shopping with your grandma? How was that new restaurant that you went to? And they look at me and say, wow, you remember that from Friday? And I stretch the truth a little bit, say, well, of course I remember it from Friday. I really remember it just because they have it on an index card. But do something to start to build those relationships, to get them feeling like you want them in that class and that they belong in your class. Part of the sense of belonging, there's some work from Rudine Sims Bishop way back from 1990. And she talked about it with children's literature, a notion of windows and mirrors. That in the children's literature that we use, we want to have our students see themselves reflected in the books. So we want our picture books for students to have pictures of Black students, brown students, different family structures, a variety of different things. But we also want that to be windows. We want to expose them to other things. Dr. Rochelle Gutierrez then took that work and she switched it to math and said, it's not just good for children's literature, it's also important for math. We want our students to see themselves in that math problems, in the work that we do. We also want to expose them to different things. Now, recognizing what may be a window for me may be a mirror for somebody else. What may be a mirror for me may be a window for somebody else. But I really like that analogy, and that really helps for me to think, where am I giving my students? Are all of my students seeing themselves in the mathematics that we're doing? And I think part of it is the names that we use in the tasks and the problems. And most curricular resources have gotten much better with this over the last decade or so, that it's not just traditionally white names, it's a variety of different names in there. But that's not enough. I think about the family structures that we use in our math problems. Most of the problems that I find ready-made all talk about mom, dad, two children. What about the family with two moms, two dads? What about the family that has a stepmom and a dad, a stepdad and a mom? What about those that have aunt and uncle as the primary caregivers? What about those that have the all those different family structures? Are we ever using any of those other family structures in our mathematics problems? Or are we using just the traditional mom, dad, two kids? What about the pronouns that we use? Are we using just he and she, or are we putting a they in there? Now, that's not just enough. Just putting a they in there is not going to help all of our students feel connected, but it does send a message to some of our students who are in the LGBTQ plus uh, community. But I think it's also, if you're saying, in my district, that's a little too risky. I don't want to use that because I may lose my job. Totally understand that different communities have different things going on politically, and we all need to keep our jobs. But what about if instead of saying, hey, boys, you do the evens, girls, you do the odds, what about our non binary students at that point in time? What about if instead we say, hey, if you were born January to June, you do the odds. If you were born July to December, you do the evens. You pick something else to do. And do our students start to see themselves better reflected in the mathematics at that point in time? What about if I'm trying to expose them to some different things? If I'm thinking about if an elementary teacher and I'm having them count things or look at different groups of objects and do some addition. Maybe I'm looking at some Chinese paper lanterns, and maybe I'm looking at how many big ones do you have, how many small ones, how many total ones do you have. If I'm working later on in elementary, middle school, high school geometry, looking at lines of symmetries, maybe I'm finding some Islamic mosaics and some Islamic kaleidoscope type of stuff, and looking at those, some of those repeating patterns, and looking at some stuff there to start to expose our students to things that they may not have normally seen. Maybe it's a mathematician of the week. And in my class, to help them see themselves as mathematicians, to help to recognize that math is continuing to grow and evolve. At the beginning of the year, I like to ask them to picture a mathematician. Have them turn to a partner and describe what a mathematician looks like. Generally, they say old, white person, male, dead, frizzy hair. And throughout the year, I expose them to a variety of different mathematicians. Here are some of them that I use. And you'll notice it's not the old, dead, white males. I do put some of the traditional ones. When we talk about Pythagorean theorem, it's a great opportunity to talk about who Pythagoras was. And it's also a great opportunity to mention, hey, the Pythagorean theorem, while it's named after Pythagoras, he probably didn't discover it. It was probably one of the people in his secret math society. And oh, really? Thousands of years before that, people knew about the relationship between those sides. Find some younger mathematicians in there. Do something to get a variety of different math so that your students are seeing different math people. And when I have students from a variety of different ethnic backgrounds, I make sure I try to find somebody from their ethnic background that's reflected as one of our mathematicians of the week. If you'd like that idea to say, I don't know even know where to start, Google not just white dude mathematicians. Annie Perkins, and I'm pretty sure she lives in the Minneapolis area. She created a website that has a whole list of mathematicians who aren't just the white dude mathematicians. It's a great place to start. If you like to have posters in your classroom, the American Math Society has some free posters. There's a poster, you see one with the LGBTQ plus mathematicians, one with some Black mathematicians, one with Latinx and Hispanics mathematicians. They're completely and totally free to educators. So that's another great opportunity. So there was our first B. I want my students to feel like they belong in my classroom. But I also want them, the second B is believing. I want them to believe that they are capable of doing math. And I would argue just having them write down step by step what to do does not convey that. It doesn't tell them that I believe that they are capable of learning that math. When I do some work with high schools sometimes, not that I'm picking on high schools here, but I know it's a way that many high school teachers do it, they have guided notes. And the students by that point in time are used to just watching what the teacher does. They copy down word for word, number for number what the teacher has, and they're not paying attention. They're busy thinking about everything but what the teacher is talking about. The teacher will even say, does anybody have any questions? They all sort of blindly nod their heads no. They have no idea what's going on. And just doing guided notes And hear me carefully, I do think you can do guided notes in a good way, and I've seen teachers who do it in a beautiful way and get those students actively engaged. But I wonder if just telling the students step by step, if that conveys them that notion that we believe that they are capable. I want them not only to feel like they belong in my classroom and build those relationships, but I want them to believe that they are capable of doing mathematics because they are capable of doing mathematics. It's really this notion about mathematics identity. And I love this book, and I love this quote from this book. If you've never read this book, The Impact of Identity in K-8 Mathematics, I encourage you to find it and read it. Now, you may be saying, I'm a high school or beyond high school teacher. There's no reason that the book could not have been called The Impact of Identity in Mathematics. They called it K-8 because the examples that they use, the classroom illustrations, are from the K-8 world. But they argue that the math identity, it's that disposition, that deeply held belief that people have about their ability to participate, to perform in mathematics. I want my students to believe that they are capable of doing the mathematics. So how can I figure out how do they think about mathematics? How do they feel about their capabilities? One of the things I like to do is have them create an emoji. Sometimes I may give them all 8 options. Sometimes I may only give them a couple of options. Let me share a couple of examples and think about what are you gaining from doing something like this. If I look at that bottom right-hand corner, there's a student when they're being challenged, they're happy. If I go sort of above and to the left, there's a student when they're being challenged, they're not quite sure how they're feeling. It's giving me some signals. It's giving me some information that I may need to relate to them a little bit differently. Now, my all-time favorite is the second one from the left. There's a student when they're struggling. They show perspiring. I get that whole idea of sweating there. But they also develop bad breath. I don't understand how that happens, but it's not for me to understand the mind of a middle schooler at all times. But this is one way that we can get some information. And I would argue we need to do things like this at the beginning of the year to find out where they're at, middle of the year, end of the year. It's not just a one and done thing. I want to see, is their identity growing? Are they starting to see themselves as more capable of math as the year progresses with the things that we're doing, with getting math by understanding rather than math by memorizing? Or is it not working for them and I need to make some tweaks along the way? So there was our second B. Our third B, I want to recognize it's an act of bravery to share your thinking in a mathematics classroom. Now, let me be clear. For most students, they're not afraid about talking in math class. It's going to talk about the math in math class that can be very challenging. So one of the things I like to do the very first day of school, in our district, we often have those little 20-minute class periods in the secondary setting because we have a half day and we do the fast and furious schedule. So I had just enough time to do, the first seating chart, attendance, all that good type of stuff. But I tell my students on that first day of school, every single one of you are going to talk today. You're all going to first correct any mispronunciation of your name. But secondly, you're going to tell me a highlight of your summer. I used to say real or imagined until that year that I had a student that said that he went to the moon and back. That was the highlight of his summer. And unfortunately, some of his more gullible 8th grade classmates thoroughly believed him and started asking all kinds of follow-up questions. So now I just ask them, what is the highlight of your summer? And by doing that, it forces every single one of my students to talk on that very first day. And I think that starts to pay dividends later on down the road. Now, if you're saying, oh, it's not really that much of an act of bravery to share your thinking, think about a staff meeting. How many of us are real willing to share our thinking in a staff meeting? Or maybe you are, but think of a colleague. How willing are they to share their thinking in the staff meeting, no matter how great of a culture? I teach in a middle school that has a wonderful culture. Our principal, our deans of students have created a very nurturing staff that likes each other. They respect each other. I've been in this building for 22, 23 years. I think I can count on one hand the number of times that I've given my input in a staff meeting. Every year, my principal says, Kevin, you need to start sharing more. You're highly respected in the building. People would love to hear what you think about topics. Every year, I tell him, I said, Chip, I'm going to work on it this year. Every year at the end of the year, he said, you didn't really get any better at it. Let's continue to work at it. So I know if I get nervous having to share my thoughts when there's sort of this little judgment thing going on, that same thing is happening for our students. And it's an act of bravery for them to be willing to share their thinking. And I wonder sometimes, is it the way that I'm having them share their thinking? So NCTM just released over the summer a new position statement around multilingual learners thriving in mathematics. And one of the recommendations in there that just really hit me in the gut was this one here. We need to center multiple modes of communication, not just speaking. Let's get them writing, drawing, doing some direct modeling, some gesturing, something, so that all of our students are actively engaged. They're learning the language and they're learning the mathematics. So how can I do that? One of the things I like to do is a which one doesn't belong. And oftentimes I do it on a Wednesday and call it Which One Wednesday. Now, my sole goal here is to just get them talking about math in that math classroom. Because I know if I do something sort of a low stakes, when I get to sort of the higher stakes in their minds, where it's the right, wrong, sharing their thinking about whatever we're discussing in mathematics, they're more willing to share if they're used to talking about it in math. So I want you to look at those four and think about which one does not belong and why. And I'll pause and give you a chance to think. If you want to throw your answer in the chat box, that's fine. If you don't want to share the chat box, that's fine. But maybe about 30 seconds to you decide which one you think does not belong and why. And you've probably noticed, and some of you may have seen things like this before, you probably noticed there is not one single answer. You may have thought 9 because it's an odd number. Because it's a one-digit number. You might have said 16 because it's the only even number. You might have noticed 43 is the only non-perfect square. It's the only prime number. My students, the first time I did this, said 9. It's the only one the digits don't add up to 7. Totally blew me away. I was thinking prime, odd, even, all those types of stuff. They're looking at summing up the digits. 25 is generally the one that's the toughest to come up with a reason for. My two favorite reasons for 25. The first one came from an educator in Texas. The educator in Texas said, hey, 25, it's the only one where the units digit is not a multiple of 3. A couple of months ago, I was in Virginia, and an educator there said 25 doesn't belong. It's the only one that you can't fill in one of the numbers. The 9, you can fill in the little circle part. The 16, you can fill in the circle part of the 6. The 43, you can fill in the 4 part of the triangle there. 25, there's nothing to fill in. But notice, more than one answer. There's no right, no wrong. Notice for some of them, there's multiple reasons for the same one. And when I'm looking at getting my students comfortable about sharing their thinking, they're willing to share their thinking with this. They want to do it. And sometimes I find that some of my most reluctant students later on, initially, who don't see themselves as a math person, don't really enjoy mathematics, they're willing to share their thinking there. And they start to get used to talking in math. And as a side bonus, they start to realize, oh, there's more than one way that we can look at something. So you can Google which one doesn't belong and you can find it. It's a free website. There's lots of different things on there. There are some with numbers. There are some with pictures. I usually alternate. Another one that I like to use to get them talking about math, and sometimes people will ask me, do you tie them into your curricular standards? No. My sole goal is just getting them to talk about the mathematics in math class. So sometimes I like to do an estimation 180, another free website. And I usually do a couple of them every Monday, call it Make It Close Monday. Here's one where, they had to figure out what approximately is the value of that bowl of pennies. I had them record their thinking, share a reason why, turn to a neighbor, do a quick turn and talk. And then a lot of times they'll say, all right, how many between 1 and 50 cents, 51 and a dollar, 101 to 150? They start to recognize there's a wide range of answers. And then I reveal the answer. On the website, there's either just straight up, here's the answer, or there's video answers. Sometimes I like to use those video answers so they can have an opportunity to adjust their thinking. But the answer for that one, to put you out of your misery, if you're wondering how many pennies are in there, $4.50 worth. And then I usually like to do two of them every Monday. And a lot of them are sort of lumped together. So the next one is, what's the value of that bowl of nickels? My eighth grades, being the brilliant mathematicians they are, grab a calculator, do 450 times 5. They're all convinced the answer is 2250 because a nickel is 5 cents. You see a couple of smirks from a couple of students, and they're like, ah, you actually stopped and thought first. Show the answer of 14. And they're like, whoa, what happened? One of the students then shares, hey, just because it has more value, it's also larger, so there's going to be less of them in there. So a couple of ideas to get our students talking about math in math class, because it is such an act of bravery to share their thinking. And when I think about, going back to that impact of identity there, I look in and say, hey, there's that learning, affirming the mathematics learning identities, drawing on multiple resources, looking at the community, the math culture around them, their family, going deep with that mathematics. Sometimes, they don't want to talk because they just don't see any value in learning that mathematics. So I want to share two other examples of getting them to talk. Is it really about the math problems that we're choosing? I can just about guarantee if you do something around gerrymandering, you can get your students to be talking about math. Now, this is a free article from NCTM. You can Google this title there, that gerrymandering when equivalent is not equal. I'm sure you can find it as a PDF. In a nutshell, here's what it's asking them to do. It says create 6 different equal districts. They usually just put the boxes around each of those 6 districts and realize, oh, the triangles won all of them. And then notice it doesn't say Democrats, Republicans. There's no politics in there at that point in time then. And then I asked them to start regrouping them. And could you have gotten different answers? Can you regroup them so that the circles end up winning some of them? Or so that the triangles just barely win? They start to recognize sometimes the way that we arrange our stuff can affect that going. And then I show them some actually gerrymandered districts. And they say, are those real? And I say, absolutely. And we have the ability to talk then about, what? Some people are using mathematics to keep themselves in power. And they look and say, whoa, I never knew math was so important. Great. Do all of my students recognize that? No, but some of my students are starting to make those connections. Thinking back to some social injustice type of stuff. We can all think of a problem. We may have done this in a middle school. We may have seen it in a high school geometry class, asking, are those similar rectangles? Do students really care about that? What about if instead we talk about the Paralympics? Maybe, to launch it, we ask them to think about some athletes they follow. Show them a little clip of a Paralympic event. Ask them, what surprised you from there? Is there anything that surprised you? How do they make the event more accessible to the players? Talking about some person first language, starting to give them some opportunities for you to share some other information. And then you show them an Olympic volleyball court and a Paralympic sitting volleyball court. Show them an Olympic soccer field and a Paralympic soccer field. Now ask them, are they similar? All of a sudden, we've given them a reason of why they may care about similar figures. We can extend it a little bit and say, create a similar skiing track to this one. Gives us an opportunity to talk about accessibility and accommodation. So sometimes it's are we choosing things that even get them interested and wanting to talk about that mathematics? So my challenge to you, as you go back in the classroom tomorrow, if you're a teacher, if you're a coach, if you're in a support type of role, as you work with teachers, what are you doing to help your students feel like they belong in your classroom? What are you doing to help your students believe that they are capable of learning mathematics because they are capable of learning mathematics? What are you doing to recognize the bravery that it takes for students to share their thinking in a mathematics classroom? So again, there's my email address. If you want a copy of the PowerPoint, I am happy to provide it for you. I just ask you to tell me you were at the Global Math Department webinar, then I know which one you are looking for. You can reach out to me there. You can connect with me via Twitter, and we can have conversations. I am happy to answer questions right now or later on. Sometimes it's 2 months down the road as you're continuing to think about something. You're like, oh, I remember this, or oh, I tried this. I wonder if. At any time, reach out to me. And I want to just conclude by saying thank you. Thank you for coming to the live event this evening, afternoon, depending on which part of the world you're in. Thanks for watching the recording. But thanks most importantly for everything that you're doing to help meet the needs of each and every one of your students in your classroom. And I wish you a great rest of the evening, afternoon, whatever the case may be.
Yep. Thank you very much for presenting, Kevin. There was one question that I posted in the chat for you, and that is, what is the best way to help parents see that memorizing as a way of doing math is not good for the students in the long term in terms of their understanding? How do you help convince the parents? Because that's how they learned,
Absolutely. So, one of the things I often do is ask them, what was your experience like in mathematics? And for most of them, they say they hated math or they didn't feel like they were good at math. So then I respond saying, do you really want your child to have that same experience? And for many caregivers, then they're like, oh, yeah, all right, good point. It probably is okay that you're doing things differently. The second thing I do, a lot of times I do that 245 plus 98 in a parent night type of stuff. And it's amazing. Most of them don't do the standard algorithm. Most of them think about it at that point in time. All right, if it was okay for you to think through 245 plus 98 and have a variety of different strategies, it's okay for your child to have those different strategies. And I acknowledge that math may look different for your child than it did for you, but I have the best interest of your students in mind. I want them to have a rich, deep math experience. I want them to leave 8th grade, in my case, feeling confident in their abilities. And for most parents, those couple of things are enough to get our caregivers sort of back on our side. So that's a great question.
Yeah. Thank you for sharing those thoughts. Yeah, that's really important to get the parents, understanding and supporting what's going on with their child in the math classroom.
Absolutely.
So that is the only question I saw, but obviously lots of thank yous in the chat. And Kevin's email address is at the top of the chat in case you missed it. So thank you very much for sharing, and thank you for everyone in attendance. Our next webinar is November 29th in 2 weeks. The title of the presentation is Statistics for Good. Let your students speak for the data with AP Statistics Guru, Darren Starnes. We hope to see many of you for that session. Good night, everyone.
Good night.